Okay, everybody, it's 7:05, so I think we should start this. So welcome everyone to the second Fossil Project webinar. Thank you so much for coming. I'm Ronnie Mike Leader, your moderator tonight. I'm a German paleobiologist and currently postdoc at the Fossil Project in Untitled Bio here at the Florida Museum of Natural History. To give a little bit of background, this webinar is part of a series we are offering in partnership with the Paleontological Society and facilitated via Untitled Bio's Adobe Connect platform. There are 4 webinars in this series, and once again, this is the second one. As always, it is free to attend the webinar, and if you are a member of MyFossil, you can get special perks for attending all 4 webinars in the series, including a completion certificate. Just contact fossil@flmnh.ufl.edu for more information. All you need in order to enter the virtual webinar room is the free Adobe Connect video conferencing software. Just check the MyFossil website for more information. And like I said, you can learn more about the rest of our webinar series and the Fossil Project in general at community.myfossil.org. We also invite everyone here, if you haven't already, to sign up and participate in the MyFossil community. Now, before we get started, just a bit of housekeeping. Today's speaker will speak for about 30 minutes, after which we will open it up for discussion and questions. So we encourage you to please take notes and write down your questions in order to facilitate discussion after the presentation. The webinar ends no later than 8 p.m. Eastern Time. Please note that you can type in the chat box at any time, but questions will be addressed during the discussion period. Microphones for attendees will be turned off throughout the webinar, so please remember to utilize the chat box to ask questions or add to the conversation. And once again, you will not need a microphone. If you can hear me and see the PowerPoint, you're good to go. We also have a very short survey that we ask you to please take some time to fill out before you leave today. You can see the link to it in the chat box, so please don't forget to take the survey after the webinar ends. If you have problems getting connected, means what to do if Adobe Connect is not your friend, there are some things you can do. Try exiting and coming back into Adobe Connect, or type in the chat box for technical support to see if we can help. Some other housekeeping rules are the following. Once again, you can type questions or make comments at any time during the webinar in the chat box. The webinar is recorded, and the PowerPoint is also freely available under resources in MyFossil. Educators who pay the nominal UF fee can earn CEUs for attending. Please contact Eleanor at fossil@flmnh.ufl.edu for more details. If you want Series 1 attendance certificate or CEU credit, you must sign into Adobe Connect with full name each time, remain and participate for the entire hour, and be a member of Fossil. That means sign up at www.community.myfossil.org. So with that, we thank you all for attending tonight's webinar, and a big thank you to our speaker for sharing your time and knowledge with us. I'm happy to introduce our speaker today, the director of the Fossil Project, curator of vertebrate paleontology and distinguished professor at University of Florida, as well as recently elected president of the Paleo Society, Professor Dr. Bruce McFadden. Bruce has conducted paleontological field research for more than 40 years and extensive experience in taking field notes. And while he was filling a dozen of field books with essential content, he's an expert. So let's turn it over to Bruce McFadden. The title of his talk is Field Notes 101. Bruce, this is your stage.
Thank you very much, Ronnie. Can you hear me? Can you hear me?
I think so, yes.
Very good. Okay. Well, thanks everybody for attending this webinar. I'd like to first acknowledge some folks. Of course, the MyFossil project team, the National Science Foundation for providing financial support of the Fossil Project, and our other partner, the Paleontological Society. I would also like to individually thank the various people related to the Fossil Webinar Support Team. Ronnie Lader, the moderator. Ellen Gardner, our coordinator for all of our logistics support. Sharon Holte, who's our technical support person. Lisa Lundgren, who is doing social media. Victor Perez is integrating real-time question and answers. So at the end of this presentation, we'll be able to address your questions. And then thanks, last but not least, to Sherry Ellis and Betty Dunkel for their survey and feedback analysis related to this webinar. So let's get started with the talk. I want to do an outline of what I hope to cover over the next 30 minutes. The first is the purpose and goals of this webinar. Why should you collect notes, field notes for fossils? And then how should you do the field notes? And how can you use emerging technologies like smartphones to help you collect field notes? Then we'll have about 25 or 30 minutes for questions, and then a final wrap up, and then we'd like you to do the survey before you sign off. Okay, the purpose and goals of this webinar, Field Notes 101, it's intended for the novice. So if you don't have any experience or minimal experience, then that's fine. However, those more experienced folks should still also find this webinar useful. I hope there's something for everybody in this that's useful. So you'll learn about why and how to take field notes. You'll be able to exchange questions and opportunity for real-time dialogue. And the intended outcome of this webinar is that you should be able to collect fossils confident in your ability to properly document your discoveries. So some interesting reflections. Lee Cohn, who's signed in and is the president of the Special Friends of the Aurora Fossil Museum. I've been out collecting fossils with Lee in various localities, and when he was in the Badlands of western Nebraska with us, he was very interested in the documentation that we take in terms of field notes. So I just want to quote some things that he said. Field notes are a very important part of an educational field trip, especially in regions of the country that you may not be familiar with. And in both my fossil trips to Nebraska and Cincinnati, I took lots of photographs, lots of pictures. When the picture is combined with the field notes, all of the meaning of the picture comes to life. So thank you, Lee, for those reflections. And with that, we'll move on to the next slide. Okay, so why take field notes? Fundamentally, the circumstances of the fossil discovery event are fundamental to the science of paleontology. Field notes document your fossil discoveries. They increase the scientific value of your fossils. They allow you to reflect on what you've learned, and these are the best practices of paleontology. So who cares about your field notes? Well, we care. Museum paleontologists care. They enhance the scientific value of your fossils. For example, I have two beautiful donations here that you can see. On the left is a Mesohippus jaw. It's probably from Nebraska or South Dakota, but we're not sure. And then this beautiful Riker mound on the right with fossil shark's teeth. It's probably from North Carolina, but we're not sure. So the point is that without any documentation, when these kinds of beautiful fossils are donated to museums, if they don't have the circumstances of the discovery and documentation, they're fine for educational kits, but they have minimal scientific values. So if you want to ultimately donate your fossils to a museum, your field notes that accompany your fossils will become critical documentation, which will make your fossils scientifically important. So how to do field notes? What do you need? Well, the first thing you need to do before you go in the field is to prepare before you collect. Now, if you've visited the fossil site before, you're likely good to go. You know what to do. But if you're going to go to a new site, you may want to consult some background information, like previous reports about the site and its rocks and fossils. You might want to look for geologic maps that show the rock outcrops or a Google Earth image of the locality. And where are you going to find these? Well, you can find these by internet searches. Thank goodness for Google searches and the internet. It's revolutionized our access to information. Why should you care about prepping before you go to a new fossil site. Because it's best to know the name of the rocks and age of and kinds of fossils that you intend to collect. It'll help you document your fossils and again make your fossils more scientifically valuable for the future. Okay, so I just saw that somebody asks what defines a fossil. We'll save that and talk about that in the Q&A at the end of my presentation. So this is a good example. Many of us have collected fossils in Belgrade, North Carolina, and the Belgrade fossil horizons from this shell mine have several different rock units, stratigraphic units. And what I did before I went to Belgrade is I consulted an article by Ward and others, 1978, which is in the lower right-hand corner of this illustration, of this slide, which is the U.S. Geological Survey Bulletin 1457F. And these are all online now, and I read about the types of rocks and the ages of the rocks that are exposed in locality 20 in Belgrade, North Carolina. That allowed me to understand where we might find Miocene land mammals to collect from the Belgrade. Now, if you collect in the Belgrade like Rob has here from the Special Friends of the Aurora Fossil Museum, he has a beautiful megalodon tooth, and he also has some other shark's teeth, and those are very common. But if you want to find in the upper right-hand corner Miocene land mammals like I'm interested in, my graduate student Victor Perez collected this astragalus or ankle bone of a fossil peccary from one of these important early Miocene localities. Without the previous work that showed this schematic diagram of the outcropping of rocks from Belgrade, and their ages and their positions, I would have not known where to look and what kinds of animals that you might anticipate, fossil animals you might anticipate collecting. Okay, so what do you need to take field notes? It's really simple. It's not sophisticated at all. What you really need only is a notebook and a pencil or a pen. I like the pen in the middle. It's a uniball, and it has a very dark ink that becomes permanent. And then the kind of field notebook that you should have high quality water resistant paper in case you get rained on. Those are sort of the optimal types of tools. And then I really believe that with emerging technologies, your smartphones have some apps which will help you to adequately document your field notes. And that's such things as Mancos. I'll talk about that. That's the kind of geologic rocks that you can find. Mancos, you can click on in the lower left-hand corner of my iPhone. There's a red and green icon for an app, and that will allow you to know what the rocks are anywhere in North America by clicking on that app. To the right and up above Mancos is Where Am I, which is a location app. Then you have your own camera integrated into the iPhone, and of course you have Google Earth. So basically, if you have a notebook and a pencil or a pen and an iPhone, you are good to go. That's what you need. All right. It's also helpful but not essential if you can find maps or reports. As I said, here we are in Panama. I wasn't sure exactly where to collect fossils, so I consulted a previous geologic map, and here we are just about to take off in our boats, and I was looking on this lake, this reservoir, for where we might find suitable age rocks based on this previous geologic map. All right, so what is the essential documentation of fossils and field notes? The field information required to scientifically document fossils, say 20 years after you collect the fossils, you or your family decide to donate your collection to a museum. What information are the museum curators going to want to know with the fossils that you have collected? Well, they're going to want to know the date collected and whether you were out in the field by yourself or with other collectors, so everybody can get credit for the discoveries. But the things in bold are really, really important. The name of the locality, the general location, I'll talk about that just a second. If you can, you need to find out what the latitude and longitude and perhaps elevation of your fossil occurrence is, the names of the rocks, and the published age. How old are the rocks? Are they Miocene? Are they 10 million years old? All these things are important. And then if you have other notes and observations, and George asked about photographs before we started the webinar, photos and their numbers of the photographs are important for future documentation, and I'll talk about all these things in just a minute. So, locality name, and these vary, and there is no strict. It's basically just an identifier, so we can know, like, if it's from Thomas Farm, Gilchrist County, Florida, Miocene, or the Chevron Formation, Sand Creek, Nebraska, Capitola Beach, Santa Cruz, California, Silophysis Quarry, Ghost Ranch, New Mexico, the Choquicota, Altiplano of Bolivia, or the San Judas Gatun Formation, Panama. All of these have information about locality. Okay, all right. Okay. So latitude and longitude is the single most informative data set to document your fossil. It's best to use, geographers have developed a convention called degree decimal, and if you look in the lower right-hand corner, it says, for example, typically we talk about latitude 9 degrees, 21 21 minutes, 8 seconds north, but that equates to 9.35217 degree decimal. And that's the convention that we use now, the degree decimal convention, for how we record both latitude and longitude. Latitude in the northern hemisphere is positive. Latitude in the southern hemisphere is negative. Longitude in the western hemisphere is negative. In the eastern hemisphere, it's positive. Excuse me, east of the Greenwich meridian is positive. If you're using a GPS device, be sure to use the correct base, which is called for North America WGS84. That's when you set up your GPS. So in the next slide, I'm going to show you different ways that you can easily take latitude and longitude. There are 4 ways here. In the upper left-hand corner is my Garmin GPS. This one was not super expensive. It's pretty precise. And here you can see it says north 29.64422 latitude, west 082.34402 longitude. So that's my Garmin. But you can simply use the compass on your iPhone if you have one. It doesn't cost anything extra. It'll give you a latitude, it'll give a longitude, and it'll give you an elevation. But the latitude and longitude and elevation are in degrees, minutes, and seconds, and then an elevation is in feet. So if you want to convert from 293844 to degree decimal, you're going to have to use. There's an easy conversion you can search for in Google. The third frame is where it's an app called Where Am I? It doesn't cost anything. It gives you both latitude and longitude in degree decimal and the more standard convention. It also gives you altitude in meters and feet. And finally, if you can locate yourself on Google Earth, in the lower right-hand corner, it's sort of hard to read, but it's in the yellow box in this photograph, in this frame. You can see that it has latitude, longitude, and altitude or elevation. So elevation or altitude is sometimes important, it's sometimes not. And if you know the latitude and longitude, you can usually reconstruct the elevation by going back in Google Earth and putting in your latitude and longitude. It'll tell you exactly where you are in terms of altitude. However, sometimes that's not such a good idea. If you're in an area with cliffs and you need if you need to know exactly where in the cliff you want to know where this fossil is, if you're just looking at latitude and longitude, you're not going to be able to know. It might be at the bottom of the cliff, it might be at the top of the cliff. It's hard to say. So it's always good if you can do latitude, longitude, and altitude all at the same time, and then somebody doesn't have to go back and reconstruct it a decade afterwards. So the other thing is rock name, and you're not going to necessarily know this, but if you use Mancos, that app that I mentioned to you, Mancos, you can just, wherever you are in North America, you can open up Mancos. It'll tell you what the rock formations are that underlie where you are. This is a good example. So rocks are usually divided into a hierarchy, and the largest, most inclusive hierarchy is the group. So in the Badlands of western Nebraska, in Toadstool Park, where Lee and I collected with a group last summer, or the summer before, I guess it was the summer before, the group that encompasses all the rocks that you see in this picture are called the White River Group. That's the blue arrow up and down on the left-hand side of this slide. Then within this group, you have two different subunits within the White River called the Chadron and Brule formations that you can see. The Chadron is the older formation because it's underneath. The Brule formation is above, and therefore it's younger. And you can further subdivide the Brule formation into the Arella and Whitney members. So in most places that have been studied by geologists, the rocks are named into different categories based on their group, their formation, and their member. And if you can write down which group, formation, or member that you're collecting your fossils from, then that's a good thing. Now, if you can't, sometimes you can reconstruct that by typing in latitude and longitude and going back into the field, going back into Google Earth, and then you can usually figure out where the formations are based in Google Earth. Yeah, the cost of Mancos is $3. The cost of Where Is It is $0. But $3, in my opinion, is a pretty darn good investment for if you want to take good field notes. The other thing you want to know is the published age of the rock unit, so you can actually write that down when you're out in the field. And that's going to, Mancos will tell you that, or if you have a report that you take into the field with you that discusses the age of the Belgrade locality or something like that, you should write those down in your field notes on the day that you were there. And here are two good examples of best practices of how folks are taking field notes from, actually, this is Sand Creek, Nebraska, which are the western Nebraska Badlands. Other notes and observations are good to write down in your field notes, like what kinds of other fossils are found there. What do the rocks look like sandstones or limestones? If you do a rough diagram or a sketch map of the area, that'll help you if you want to go back there in the future. It'll help you to try to remember where you were. If you can draw a rough rock column, and I'll show you what one of those are like, and geologists call that a strat section or a stratigraphic section, and then whether the fossils that you collect were collected in the rock themselves, and we use the word in situ, versus out of context, just rolling along the bottom of the outcrop. Out of context, that's called float. So whether your fossils are in situ or float is important to understand their context. So here's an example in the Gatun Formation of Panama. The person in the left near the cliff is looking for fossils that are in situ, because all those little white dots in these 10-million-year-old fossil deposits are fossils. So that person, when they collect those fossils in the cliffs, are collecting fossils in place. Whereas the person with the red shirt and the hat looking down on the ground, there's also fossils where he is, but those fossils are most likely, they were washed down off the cliffs and onto those flats, and those are most likely out of context, and therefore they're called float. Okay, George talked about photography, photographs, and iPhones, and integrating field notes with photographs are essential documentation for being able to find out where you were. I'll give you an example. When I was working in Bolivia 12 years ago in the Altiplano of Bolivia on May 30th, 2004, at latitude -17, so that's in the southern hemisphere, and longitude 68.3, that's in the western hemisphere, at an elevation of 12,680 feet. Yeah, that's pretty high up in the Altiplano in the Andes Mountains. We were collecting fossils that are about 10 million years old from this outcrop of rocks in a place called Choquicota, and I took this photograph 12 years ago. When I was preparing for this talk, I wanted to show a photograph that had a documentation that you could go back and look at the original field notes. So I looked at this image 0985, And then I went into my field notes from 2004, and if you look at my Bruce's field notes in the lower left-hand corner, it says photo 1090985. So, and then I drew a diagram of the rocks, a vertical column, and I say it was about 150 meters thick. There were bones, like rodents, and then there was a skull in the upper part of the section. And in the middle of this rock section, there was a prominent ash. And you can see that in the rock section, in the lower part, there's a distinctive white zone. That is a volcanic ash that has that has a chemical date of 5.5 million years. And if you look really closely, all the way up at the top of this rock column, very, very closely, there are two people. And they were collecting a partial skull of an animal called a nodal ungulate. So I know that fossil, which is in our museum, I know exactly where it was collected from 12 years ago. I could go back and put my finger on exactly the locality because of the fact that I took latitude and longitude and elevation. I had field notes that diagram the circumstances of the discovery, and I have photographic documentation as well to back it up. Okay, more on the value of field notes. If you want to share your photos in the MyFossil photo gallery, it'll be good for you to have the documentation like city, county, state, country, latitude, longitude. All these things are important documentation, as well as the age. And if you want to know more about how to upload your fossils, if you already haven't done so, and if you want to upload your fossils to our gallery, you can ask us, or we'll help you get started if you need to be. But this is some of the documentation that improves the value of your collections. So concluding comments, field notes. Field notes document the scientific value of fossils. They consist of several important kinds of data that we've discussed. Some are more important than others because some data can be reconstructed. The emphasis that I want to place on here is that latitude and longitude are super important, and typically folks don't necessarily take latitude and longitude data, but with new smartphone technology, it's a piece of cake. It's not easy. It's not difficult at all. And by taking these kinds of data, these data will allow you to better learn and recall what you collected 10 or 20 years later, and it will increase the scientific value of the fossils for the future. Okay, so now we have questions, and so I'm going to ask. There's been a lot of chat, and that's really wonderful. And what I'd like now is for Ronnie or Victor to start asking, to synthesize, and let's talk. Let me see if I can field some of the questions.
So okay, I'm taking it for now. So first of all,
okay, thank you, Ronnie.
Yeah, thank you so much, Bruce. I guess this is great information and great tips that I think many people will find very useful. So now we open it up to everyone for question and discussion. So you can type now your questions in the chat box, and I will read each one out loud. Okay, so I'm going to just look. Okay, go ahead and read them out loud. I'll wait for you to synthesize them, Ronnie. Okay, so while you were talking, we were writing down some questions. So the first one is, do you draw diagrams in the field or after? No. You got to draw the diagrams when it's fresh in your memory and you can look at the rocks. So if you remember the case in the Altiplano of Bolivia, I sat down, opened up my book, took a break, and wrote the diagram in the field where I could confirm or validate what I was writing by looking at the rocks themselves. It's not a good idea. It's not best practice to go back at night and do your diagrams. You should do it when you're in the field. Okay. So the next question, are photos just as good or better than drawings? Well, the drawings help you to interpret. It's a schematic. Both of them are good. Both of them have their strengths. So I wouldn't say that one is better than the other, although they're both good. Diagrams interpret what you see. Photographs let you see exactly what's there. So they're both important. Mm-hmm. Next question, what GPS coordinate format should be used, and do I have to update the datum?
So you should the datum that you should use if you're configuring a GPS, a handheld GPS, for example, is WGS84, which is the convention, the base for taking measurements of latitude and longitude in North America.
Mm-hmm. Next question, do you prefer electronic or handwritten notes?
Good question. I think in the future we'll be seeing more people using iPads for notes. I have a problem with iPads because of the glare in the sun. I'm sort of old-fashioned in that regard, and I enjoy the process of writing in a field notebook.
Mm-hmm. Then this is a good question. Should I get a notebook with lines or grid and graph? And
it doesn't really matter. Some field notebooks have a grid on one page and lines on the other. It depends upon what you like. I've been using K&E field notebooks for 40 years, or Dietzen field notebooks, and they're pretty consistent. They use a grid on one side to draw sections that you can calibrate, and on the right hand side you can take notes. But really, it's personal preference.
There's a question that is related to that. Do you prefer acid-free paper?
Well, it sort of depends upon, to me, the most important thing is that your paper is waterproof. That if you get it wet afterwards, that the ink is not going to fade or bleed. So you need to get a pen that has good permanent ink. I like those Uniballs that I said, which are pretty good. So my preference would be to get a field book that has high quality paper. It doesn't have to be acid-free paper, in my opinion.
Mm-hmm. Next question: is it better to collect samples, draw, or photograph, or altogether?
I would do well. It depends upon what is the objective of your field work. To me, the more things that you can do, the more information that you can gather about your fossil discoveries, the better that is.
Okay, that's an interesting question. How do field notes help in cataloging your collection?
Absolutely, that's a fabulous question. Museum paleontologists have a standard set of data entries on their database. So they need to know the location of your fossil, which we've discussed. They need to know who collected it, which we discussed. They need to know its specific location in terms of coordinates. We discussed latitude and longitude. We discussed altitude. We discussed the kinds of rocks that are there. And then we discussed the age of the rocks. Those are the core or essential elements of data that when a museum paleontologist is cataloging fossils, they need to know that information. Other information like what the fossil is, whether it's an upper tooth or a shell, that's obvious from the fossil. Okay, you don't need to write that in your field notes because it's obvious. If your field notes are in the same bag as your fossil, for example, or there's some numerical referencing system. So bag number 1 has a fossil horse specimen from the Pleistocene of Texas or something like that. So those are the essential data that the museum scientists, if these fossils are ever going to be cataloged in the future, they'll want to know.
Okay. There's another very good question. Do field notes only apply to fossils?
No. Any good field geologist takes field notes. Whether they study the arrangements of the rocks, the kinds of rocks, their what are called structure. All field geologists take field notes. It's an essential component of what we do as geologists and paleontologists.
And is it just in geology?
Well, if you're in biology, any scientist working out in the field is well served by taking notes that document what they're collecting. If you're collecting, field notes are really important to document the circumstances and context of what you're collecting.
Okay. There's a more general question. What defines a fossil, and what are the different types of fossils?
Yeah. So that also is a good question. To me, a fossil is something that's been changed chemically or petrified, turned to stone. Some people say that fossils have to be a certain number of years old, whether it's 10,000 or 15,000 years old or whatever. To me, it's more about the if all of the organic materials are disintegrated and the fossil itself, the bone or the shells, are petrified or turned to stone, to me that's the process of fossilization. There are various types of fossils. There are fossil vertebrates. I study fossil horses and other fossil mammals. There are fossil invertebrates, which are shells and starfish and coral and sponges and things like that. And then there are what's called microfossils. So animals that lived in the plankton that become fossilized when they die and their shells settle to the bottom of the ocean, that's called microfossils. So there are four major categories of fossils, what are called body fossils. And then there are also another category of fossils called trace fossils, which are tracks of animals when they moved around and that those tracks were fossilized. That's another kind of fossil.
Okay, thanks. So next one, what is the easiest way to identify a fossil of animal if you don't know the species, genus, and so on?
Yeah, so that takes a lot of practice. If you're out in the field with somebody else who knows the ropes, so to speak, they've been there before, they probably know that. And you'll want to have that person mentor you because they can share information with you. There are online atlases, so if you go to the Belgrade Quarry or you collect fossils and fossil shark's teeth in another locality, there'll be some publications that will describe the fossils, and you'll want to compare the fossils that you're finding with fossils that have previously been discovered from that particular locality. Sometimes it's fairly easy, sometimes it's complicated.
Okay, and how can the field notebook help you identifying the fossils? How can your field notes help you? What's the scientific value of that?
The scientific value is that it documents, so let's say you collect many different fossils and you're walking in different rock units over the course of a day, and once you get back from the field, or maybe you put those fossils in the garage and a month later you come back, it's happened to me before, and maybe you're not so sure where you collected those if they're not properly documented. What happens then is the value of those particular fossils is diminished.
And what means scientific value?
The scientific value, correct. Oh, what is the meaning of scientific value? The meaning of scientific value is when those fossils carry a lot of important information. When they lived, what kinds of fossils they were, and the scientific value of those fossils are only good enough when they're associated with the kind of data that the kind of information and data that we've been talking about collecting as part of Field Notes 101.
Okay, next question. How does latitude and longitude work in the field where there is no cell signal?
Good question. So if you want to do latitude and longitude and use your cell phone, you have to make sure obviously that there is cell phone coverage. If that's not going to work, then you'll probably have to use a GPS, which will tie in directly to satellite navigation.
Mm-hmm. And there's another question. What info should go on plaster and jackets in the field?
Enough info that you can tie. So another thing you can do is you can determine, you can give your fossils what are called field numbers. So what I like to do is today's September 29th, 2016, and let's say I was in the field today collecting a series of fossils. I'd have some collecting bags. They can be high quality Ziplocs. That's what I like to use. And what you could do is you could just say, you could put sample number 9/29/2016 dash sample number 1, put that in a Ziploc bag, and put the information on that, and then also transfer that same information, that same number, into your field notebook. And every time you go to a new locality during that day, you then would have different field locality notes that could be connected back to the samples in your plastic bags.
Okay, there's another very good question. Do you record every fossil you find? And what if you find a lot of shark teeth that are all in the same? Example is a Belgrade quarry.
I'd put them in the same bag. Okay, let's say you find 100 shark's teeth in a morning and they're all from the same area. What I would do is put them in one bag, and then I would label that bag September 29th, 2016. Sample number 1 or sample number 10. It doesn't matter, whatever. And then all the information that you collect about latitude and longitude and formation, etc., would go along with that. That's called a lot, cataloging by lot. There are different ways that scientists catalog, which is a whole different story, and it's probably the stuff for a different webinar. But basically, you can catalog individual fossils, one by one, or you can catalog fossils in the field within what are called lots, which lots are just more than one individual fossil. So I might have a lot of 89 shark's teeth that I collected within a meter square in a very rich fossil site, like the way Lee Creek used to be in North Carolina, where there's fossil after fossil after fossil. You can put all those in the same bag, give them a sample number, collect and put that sample number in the book. Collect all the information, the latitude, longitude, and then you're good to go.
Okay, next question. What makes good field notes when studying things other than fossils?
Well, that's a pretty general question. Good field notes to me is the date that you collected something. It really depends. If you're a biologist and you want to know something about the local forests or grasslands or something, you want to know the date that they were collected. You might want to know what time of day if you're a bird watcher, because some birds are more active in the morning and some birds are more active, in the middle of the day. So it really depends upon what are the goals for your field notes. My webinar today was focused primarily on fossils and the kinds of information that would be collected to maximize the information for your fossil collections.
Okay, this is a very specific question. How detailed is Mancos, and does it go to member level?
That's a good question. I think it is. I've used Mancos a little bit. I just downloaded it about a month ago. It has a lot of potential, and I think it continues to improve. In some places, the information is more detailed, and others less so. I think it will only continue to improve in the future.
Okay, and this is also a good question. Do you take field notes with other scientists or independently?
I like to take my own field notes. Every scientist typically likes to take their own field notes. So to answer your question, I like to take my own notes.
Okay, and there's another question that's related to that. Do you share your field notebooks with other paleontologists?
If they're interested, absolutely. Why not?
Do you collect them?
Do I collect what, field notes? Field notebooks? Yeah, I have all my field notebooks in my shelf in my office going back to 1972 when I was a graduate student in New Mexico and I was mapping the geology of a fossil locality north of Santa Fe for my doctoral dissertation. I still have those field notes.
And how many?
How many field notes do I have?
Yes.
How many field notebooks?
Yes, I guess that's the question.
I have about a dozen field notebooks that span from the past 40 years. And we can post a picture of those if you want. But yeah, I have all my field notes. They're important to archive, so somebody could go back, read my field notes if I'm not around, and they can see where I collected fossils in 1973 in August when I was a graduate student doing my doctoral dissertation field work. So really, the importance of field notes is that they preserve the value and integrity of your fossils in perpetuity.
Okay, so this is probably the last question I have so far. If you have a full horse skeleton, should you catalog the whole skeleton or each bone individually?
You should. That's a very good question. If you collect a complete individual skeleton, whether it's a horse from the Pleistocene or if it's a Oreodont from the Badlands of western Nebraska, and you know that it's a single individual, that should be cataloged as one number only. You do not need to give every bone a separate number. If you're sure that it's from the same individual, it only needs one number. And that's actually the way that the museum curators are going to catalog it as well in their collections databases.
Okay, I guess this concludes this presentation now. So, is there another question? There is one. How do field notes help with cataloging your fossils?
Yeah, the field notes will give you the information that you need to catalog your fossils the way that the way that a museum scientist and paleontologist would as well. We need to wrap up because we want to end at 8, and we want everybody to have an opportunity to do the survey. The surveys are really important to us because we want to know feedback from you. And then I think there's a final wrap-up slide, Ronnie. We're going to need to change the screen here. I don't know if I should reconfigure the chat and then go on to the final wrap-up slide, and then you can wrap up. There we go. Good. Okay, so there we go. Go ahead, Ronnie. I'll turn it over to you.
Okay, thank you so much. So this concludes the presentation. So thank you so much to all the attendees. All I need to say now is that the next 2 webinars in the series are on October 19th. The topic is excavating fossils with David Butler of Montana State University. And then on November 30th, fossil prep basics with Rachel Narducci from our Florida Museum of Natural History. Like Bruce mentioned, the webinar concludes with a short 5 to 10 minutes feedback survey that you should see now. There's the link. You should also visit us at MyFossil to access this PowerPoint, all the recorded webinars, and just to participate in webinar forum or just connect with others. So all I have to say now is thank you all for attending. And once again, please don't forget to complete the short survey. And
thank you, thank you, Ronnie, very much, and thank you to everyone who attended the webinar. We really appreciate your interest.
Yes, we do.
So I'm going to sign off. Thank you very much.
Thank you, Bruce. So I think